Okay, so when we look at our mean, variance, and standard deviation, but when we have altered values, which we call an assumed mean, we can use these altered values and we work backwards to get real values, or we use the altered values to find our variance, etc. So what I mean when I'm saying altered values with the assumed mean is I can take my sum of x values that I've used before in the mean, and I can subtract or add, depending on a specific value from each of those x values. So I usually take it away because it means I've got really big values sometimes, and I want to rather work with smaller ones. So I take a specific number away from each value so that I can work with those smaller ones, and then I will get what I call the assumed mean. I can do the same thing with my squared values by taking a specific number away from each x first and then squaring them all together. So what it actually means, if I'm using these altered values and I want to get a mean, it means that I've taken away a specific value from my sum of x over n, which is my mean formula, but the real mean means I have to add back the value that I took away. If I'm working with variance though, these altered values cancel each other out. So if I use an altered value for squared, I can use an altered value for mean because it will level out to exactly the same thing. I can also work backwards and use the original, but sometimes it's easier to just use the altered values that are given, and then it'll save you time because it'll still work out to the same answer. So if I look at some examples of this, so I have time in seconds of students that were swimming 100 meters, okay, and recorded for 9 different swimmers, and they were found as the following times. And now I need to find the values of sum of t minus 120 and sum of t minus 120 squared. So what this is saying is for each time in t seconds, I'm subtracting 120 away from that. So in order to find the sum of my t minus 120, it means for each individual value, I took 120 away. So my first one was 95, and I minused 120 from it. Then, because I'm dealing with sum of, I'm going to add, my next one was 126 minus 120. Thus, 117 minus 120. And you're going to go and do that same thing for each of those values. So, 135 minus 120, 120 minus 120, 125 minus 120, 114 minus 120, 19 minus 120, and then my last one, 136 minus 120. So if in your calculator you do each one of those individually, so 95 minus 120 is going to work out to minus 25. 126 minus 120 is 6. And if we keep going, we get each of our individual values. And now, if you add all of those individual values up, you will get a final answer for the sum of t minus 120. So then, the sum of t minus 120 squared means first I took 120 away, which means the same as that, and then I squared my answer. So it's the same as saying that squared, squared, squared. So I can just take those same values, and now I'm going to square them. Added to the next one, squared. And then when you add all of those squared values into the calculator, you get a final answer. So now I've got the sum of t minus 120, and I've got the sum of t minus 120 squared, because I took 120 away from each of my individual values. So then, the next part of the question says, using your values that you just found, calculate the variance of t. So now, because I have just made altered values, and I have a sum of t minus 120 and a sum of t minus 120 squared, I can use both of those and just use my variance formula, because my variance formula is going to be my sum of t minus 120 squared, because it's my altered values, and usually I would have said sum of x squared, divided by n minus the mean squared. And for the mean squared, I'm going to use the altered value because I'm using the altered value here. So I would just say then the sum of t minus 120 over n, and that whole thing squared, because that will then give me the mean, because the mean is the sum of over n. So if I sub in the values I just worked out, over n, I'm told it was 9 swimmers, minus my sum of t minus 120 of 7 over 9 swimmers, all squared. And when you type that into your calculator, you get a final answer, which would be exactly the same as if I worked backwards and took each of these individual values and said sum of x and sum of x squared. It's just easier to work with slightly small numbers than it would be to work with these huge numbers. So that's why we do it. So if I look at another example, I've got, for n values of a variable x, it is given that the sum of x minus 50 is 154, and the sum of x is 944. And I need to find the value of n. So, for this value over here, it means that for every x value, I took 50 away. For every single one of them to get my total. Over here, I've literally just added up all my x values together. So if I want to find n, I can use both of these and put them together, because what this one was saying was I took the sum of x, because I added all the x's together, but from all those x's, I took away 50 each individual time. So that is 50 n times, because that is every single value. And that would then give me the original sum of x value. Okay, because I've got my sum of x, I've got minus 50n, and that's telling me sum of x minus 50 was 144. The sum of x that I was originally told was 944. And from that, I took n away 50 times to get my other option. And now I have an equation where the only thing missing is n. So I can then solve for n by taking that to the other side, changing the sign, and then dividing by 50 to get n. And if you do that, you get a final answer of 16 for n. Okay, so we've just got to remember, in general, when I'm dealing with a mean, okay, the mean is the average value. So that's just one separate value, and that's why we can just add back one of our values of a, because the mean is the same as saying one middle value. But if I'm dealing with a sum of x, a sum of x means I've added all the x's together and I took a value away for every single one of those. So that's why it's n times that value that I took away, because that's how many times I took something away from the sum of x, as opposed to the mean, which is just one value. Okay, so if I look at a different example, So for 40 values of the variable x, it is given that the sum of x minus c squared is 3099.2, where c is a constant and the standard deviation for these values of x is 3.2. The first thing I'm asked to do is find the value of sum of x minus c. So if I want to find the sum of x minus c, the information I'm given is the sum of x minus c squared, and I'm given the standard deviation. So I know that the standard deviation is the square root of the variance. So that means that the variance is going to be the standard deviation squared, because our opposite of our square root is to square it. And I know the formula for my variance is going to be the sum of x minus c squared over n minus my sum of x minus c over n squared. So now the variance is going to be the standard deviation squared. So that is 3.2 squared. The sum of x minus c squared I've already been given as 3099.2, and n is because there are 40 values. So I'm going to divide that by n. Minus the sum of x minus c, which I don't have because that's what I need to work out, over n, which is going to be 40, all squared. So now in this equation, I only have that sum of x minus c that's missing. So now I can solve for it, because I can take this over to that side, or I can simply just switch those around. Okay, and I can end up with my sum of x minus c over 40 squared is going to equal to 67.24. Okay, because if I switch places, it means I'm going to take that over that minus that squared. And then to get my sum of x minus c on its own, I would square root it to get rid of the squared and take that to that side to multiply to get my final answer of 328. Okay, so then the second part of that says, given that c equals 50, find the mean of these values of x. So that means I want the real mean, okay? Because anytime that you're given a mean in the situation like this, it's always for the real original values. And you're going to use those original values to change the mean or vice versa. Okay, so now I'm told that c is 50. I have already just worked out my sum of x minus c. Okay, I already have n, so I can say that the real mean is going to be my sum of x minus the c over n, but because I want the real value, I need to add back that c. And I'm told that c is 50, so that's going to be plus 50 because I'm adding it back in. So that means that the sum of x minus c that I just worked out of 328 over n of 40 plus adding back the 50 will give me a final answer for my mean. Okay, so then what other kind of question we're going to get? So now I have that Swati measured the length in x centimeters of 18 stick insects and found that the sum of x squared was 967. Given that the mean length is 58 over 9 centimeters, find the values of sum of x minus 5 and sum of x minus 5 squared. So unlike the first one where we were given all the values and we could simply just subtract away, now I don't have the values, but I still need to find any of those altered values where I've taken 5 away. Now again, where it says given that the mean length is that. That is the original mean length before I took anything away. But I can still use all these values to solve for what I want. So the first bit of information that I'm given, I've got the mean, and I have got n, because I'm told it's of 18 stick insects. So I know that a mean is going to equal to sum of x over n. I'm given that the mean is 58 over 9. It's going to equal the sum of x, and n is 18. So that means I can work out sum of x alone by saying 58 over 9 times by 18. And I'm going to get that the sum of x is 116 when I do that. So now that I have got the original sum of x, a sum of x minus 5 means I took 5 away from each x value, and I had 18 x values. So from each of those 18 values, I took 5 away. So that means that a sum of x minus 5 would be the same as saying the sum of x minus 5 n times. And I have the sum of x, I have 5, and I know that I took that away 18 times. So that means that I can add that in my calculator and I get a total value of 26 for the sum of x minus 5. So now, all that's left is I need to find the sum of x minus 5 squared. And I know that the variance is the same whether I take 5 away or whether I use my original values. So because the variance would work out the same as long as I've used the same set of data, so the minus 5s together and the minus 5 squared or the originals, the variance is the same. So what I can do is I can say that the variance formula of the one set of the original information is going to equal the same as the variance formula of the other set. So by saying that, it means I'm going to say my variance formula is the sum of x minus 5 squared over n minus my sum of x minus 5 over n squared, because that's the mean. So because those, I'm using the same set, that variance would be the same as saying sum of x squared over n minus my sum of x over n squared, because that's the original. So that's the original squared values and the original mean. And because I was told the original sum of x, I've worked out this sum of x squared and I've worked out the original sum of x. It means that if I sub in everything I know, I'm going to be left with just that one that I want, because I've got the sum of x minus 5 squared over n, which was 18 insects, minus the sum of x minus 5 I just worked out was 26 over n, which is 18 squared, is going to equal the sum of x squared, which I am told up there is 967 over n, which is 18, minus sum of x, which I have worked out as 116 over n, which is 18, same as saying 58 over 9 squared. And now I have got everything except that value. So now I can solve for that by adding this into my calculator, taking this over to that side and adding it, and then multiplying the entire thing by that 18 value. And if you do that, you will end up with a sum of x minus 5 squared value of 257. Okay, so just always remember that if I've got altered values together with that variance, it's going to end up with the same as the original values in the variance formula. And whenever I'm taking something away from a mean, it means I need to add it back to get the original. Okay, so those are the kinds of questions you can get when I want an altered value for assumed mean types of questions. Okay, and then there's just one more example that I want to show you, but using original values for original mean questions. So something like this, for example, okay. If I have two separate companies, okay, for 11 employees, and I'm given all the data, but I need, given that the new employee joins that company and the mean salary of the new 12 employees is $38,500, find the salary of the new employee. So if I'm given a mean and information, sometimes I'm asked to see what will happen if I'm given a new value and calculate the original difference. So in something like this, I've been given all the information for company B. So the first thing that I can do is I can find the sum of x, because the sum of x is just adding all of those together. So a sum of x is going to be 26 plus 47 plus 30 plus 52 plus 41 plus 38 plus 35 plus 42 plus 49 plus 31 plus 42. So that is 433,000, okay, because the units were thousands. So don't forget to add in those thousands for that. So that's the original sum of x. And now I'm told that the mean of 12 employees is 38,500. So a new mean is the same as saying sum of x of the new values over my new n. So that means that it's going to be 38,500 equals the sum of x of those new values over 12. So I can solve for the sum of x of the new values by taking that to that side and multiplying, and I end up with the sum of x of the new values being 462,000. So now I have the original sum of x and the new sum of x, and the difference between them would be that one extra x value that I added in. So I'm going to say my 462,000 minus the original is going to give me that one value that I added in. Okay, so you can use any information to find anything you want as long as you can put it into a formula and one thing is unknown.